Hi, and welcome to our first of two maths lessons around trigonometry. So my apologies, I couldn't actually be there for these two. Hopefully this is the next best thing and it still allows everyone to keep working as if I was there. So we're continuing on, as I said, with trigonometry. We've done all the basic rules and formulas that we could and that we need to know. And now we're sort of moving into the more problem-solving area of trigonometry, where we need to take everything that we've learned so far and be able to apply it in questions that need us to. So, as it says here, in the maths course, there's two things that we really that make our job a little easier. The first one is that in these problem-solving questions, you're always going to be given the diagram, as it says at the bottom there, which really frees up a lot of the interpretation into just what do I need to do, as opposed to what does this actually even look like in the first place. And the second part is that of these two triangle questions, which will typically be your problem-solving ones, one of them is always going to be a right-angled triangle. So in terms of our flowchart, you know that the very first question is one of our triangles right, or is the triangle right-angled? And if it is, it becomes really easy because we can use SOHCAHTOA. And we're going to have an opportunity to do that in each and every one of these questions you'll be faced with. So speaking of that flowchart, we'll just skip on, and I briefly summarised it into a worded form. So if the question has a right angle triangle, you can use sine, cos and tan, or your SOHCAHTOA. If the question does not have a right angle triangle, or if there is a non-right angle triangle involved, there are two options. And you need to ask yourself, what kind of information am I given? So the part where you're able to use the sine rule is when you have two angles and two sides. And the part that says, all right, I need to use the cosine rule or the cos rule, is you're given one angle but three side lengths. And they're the things we need to keep in mind heading into these questions. So first up for our example, we have all the information as previously described. The diagram's given to us and one of the triangles is right angled for us. So having a look here, a watchman observes a ship from two observation windows where one is 8 meters above the other. From the upper window, the angle of depression is 35 degrees, and from the lower window, the angle of depression is 26 degrees. How far away is the boat? Now, all of this information is marked on here for you, and we'll just make a few a little more clear than what they are. So that 35 degrees is the angle in there, and the 26 degrees is that angle in there. Now, remembering back to our alternate angles knowledge, or whenever we're given these angles of depression, they directly translate into an angle in the triangle itself. So the 35 degrees, it's going to sort of start to overlap a bit here, so hopefully I can get it to do what I want it to do. So the 35 degrees is this entire angle here. And the 26 degrees is only this angle in here, and that's what it translates into. So at the moment, the information that was given to us being angles of depression, the angles themselves were outside the triangles that we're going to deal with, so we needed some way of putting them in so that they're actually useful information, and alternate angles is the way to do that. Okay, so I'm going to give myself a bit of room. We've got the information in the diagram, and we need some room to do some working out. All right, to find that D. Now, there's a range of different ways you can do this, and that is to say that there's no right or wrong way of going about it, as long as what you're doing fits the formulas, applies all the trigonometry rules. It doesn't matter if you turn left or turn right, or how many different turns you make. Whatever you do, as long as it is right in the first place, you'll end up at the answer you need. So it's a little bit of find your own path and find what you're comfortable with. I'll try and explain my way as much as I can so that you've got a bit of justification behind it. And if you have a different way, then you'll hear how I explain my way. You'll be able to explain your way to yourself to make sure that it's right or not. So for me, I always notice that these two triangle problems always involve a right angle, as it says, and the right angle is down here. And you'll start to notice a bit of a pattern that the right angle triangle is always dealt with second, and you always need to do something with the non-right angle triangle first, define some sort of angle or length about the right angle triangle, and then you're pretty much SOHCAHTOA to get your final length or angle that you need. Looking at this one here, I'm going to try and fill in a bit of information to help myself out. Now, I'm going to do it all in red, so you can see the information that hasn't been given to us, but it's so simple and so basic that it may as well have. So up here with our 35 degrees, that's a right angle there. So our 90 minus our 35 means that this angle in here is 55 degrees. So that's something we can quickly work out. It may be useful, it may not be. Likewise, down here, at the bottom left where the ship is, just realise that you're not really looking at where I'm pointing to. But if we've got 35 degrees all up, 26 degrees in one triangle, that leaves 9 degrees in that triangle, or that little angle there. May be useful, may not be. And that's about it in terms of angles of what we can pull out of without actually doing too much hard calculations. Okay, how are we going to solve this? As I said, the right angled triangle usually comes second, so I'm going to focus on looking at the information given to us in the non-right angled triangle. What would help me to work out the D down here in the right angled triangle? I've got one angle, I've got one side length, so another side length would be useful. And we've got the tower, but we have no more information about the tower, so I can't really go, all right, well, the tower's 20 metres tall, that's 8, so the leftovers must be 12 or something like that. The only real way that we're going to do it is if we calculate the length of the hypotenuse, which is one side length of the non-right angled triangle. It's the longest side length of our right angled triangle. That way we've got two side lengths and an angle we can use SOHCAHTOA. So that's what I'm going to be aiming for. I'm going to find the length of this one right here. I'm going to call that X. Okay, I've got 9 degrees inside that non-right angled triangle. I've got an X. I've got an 8 meters. And I've got, what else have I got? I've got the 55 degrees in there as well. So, thinking about non-right angle triangle rules, we've got the sine rule where we have 2 angles and 2 side lengths, or we've got the cosine rule where we need 3 side lengths and 1 angle. We have an 8 meters and an X, and we have a 9 and a 55 degrees. So that's 2 side lengths and 2 angles. Now I apologise for the way that this diagram's turning out. I might just clear a bit of stuff and free up what we don't need. So get rid of that. Move that down there. Don't need that there. That. Okay, let's free it up a bit. Finish this red line back off. Alright, we'll start to use a few more colours again. So this 9 degrees is opposite the side length of 8 meters, and this 55 degrees angle is opposite the side length of X. Now we're looking for the side length, so our sine rule starts to become side length over sine of the angle opposite to it equals another side length divided by sine of the angle opposite that side length. That's our sine rule. Filling in the bits of information that we're given. It doesn't matter which one's A and which one's B. As you can see, and remember back to the lesson, the sine rule is more of like a sine ratio. It's just a way that our angles and side lengths can be related to each other. So I'm going to start with, I really like my unknowns to be on the left. So my missing side length X is going to be on the left and divided by sine of the angle that is opposite X, which is 55. That will be equal to the other bit of information I've got, which is the side length of 8 divided by sine of the angle that is opposite that one, which is 9 degrees. Alright, look at that. The magic of technology. I forgot my calculator, so I ran off and got it, and you guys don't even know. Back to this problem though. We have a missing side length x over sine 55 is equal to 8 over sine of 9 degrees. Now what we need to be able to do is separate our sine 55 from our x. We need to move it to the other side of our equal sign. At the moment it's being divided by the x, so the opposite of that is multiply. And we end up with x equals 8 over sine of 9 multiplied by sine of 55. Doing that quickly on our calculator, 8 over sine of 9 multiplied by sine of 55, and that gives us 41, roughly 41.9 meters. With this new bit of information, that is now here. I'll label that instead of the x. Get rid of that x. Put on our 41.9 and meters. So now the bits of information that we've got is the angle down in here, which was 26 degrees. We've got our d. We've got our 41.9. Now that d in relation to the 26 degrees is adjacent, and our 41.9 is the hypotenuse, so that means we're using cos. So we end up with cos of the angle equals a over h, filling in the bits of information we got. Cos of 26 is equal to our missing side length d over 41.9. Taking our 41.9 over to the other side by multiplying, that leaves us with d is equal to 41.9 multiplied by cos of 26 degrees. Grabbing our calculator, quickly doing that. 41.9 multiplied by cos of 26, and that leaves us with pretty much 37.7. And then you would go on to say something about the boat is 37.7 meters away from the lighthouse. Alright, that's pretty much the workload that is expected from one of these questions. You can see there that there's, on the left, we've got one set of working out to find a missing side length or angle, and then once we have found that, on the right down the bottom, we then use it in some sort of sine, cos or tan ratio to find the missing bit of information that the question was actually asking for. And it's these kind of two-step processes that are pretty much going to be expected for the rest of the questions. Now, I've been talking for about 10 minutes, so because this is a video, you don't really need to watch the whole thing. I'm going to move on, do both examples, but if you're feeling pretty confident at any stage, just stop watching this and head on with the questions uploaded in our Trigonometry Schoology folder. Okay, next one. Use the following information to calculate the distance from point B to point C. Now the following information is given to us in diagram form straight away, so there's no big spiel at the front. We don't need to worry about interpreting. The only thing we really need to know is what are we actually looking for? Point B is over here and point C is over here, and we need the distance between there. So that is what we're actually aiming for. Now, because of that, we can start to talk about, all right, well, it's looking for the entire side length of a big triangle, a big right-angled triangle. And that's one way you could go about this, is you could find another side length, possibly from A to B, if possible, and then use sine, cos, or tan to then work out the side length of x. Or the other way, and the way that I'll be having a look at, is, all right, I've already got from B to D, and that's 23. So all I need to find is from C to D, which I'll call y because I've already used x. Once I've got that, I can add on my 23, and then that will give me the distance I need. So there are a whole bunch of ways you can do this. It's really up to you with what one you feel more comfortable. I'm going to be doing mine pretty much the same way we did the last question. Use the non-right angled triangle to find out some piece of missing information, then use that in the right angle triangle to find my missing length. All right, let's have a look at what we got and what we can work out. In our non-right angled triangle, angle B is 40 degrees, and here at intersection D, if we go, all right, that's a straight line, so all the way over is 180 degrees. We've already got 60, so that must mean this angle in here is 120 degrees. Then we can say, all right, there's 180 degrees inside a triangle. This non-right angle triangle, we've got the 120, we've got a 40, which takes us up to 160. So that must mean the third corner left is 20 degrees. Other than that, we don't really know much else about the point A, so we can't then work out the angle inside the right angle bit because we don't know how much it is to start with. So I don't even know where we're going with this. It's just a matter of what have I got and what can I work out. The more information you have at the start of a question, the much easier it's going to be, and the more likelihood there is of you picking the way that you really like best. A lot of the information given to you either assumes that you will find out everything else, or it sort of leads you in one direction, and that direction may not be your strength. So go ahead, find all the other bits of angles that you can, just to help yourself out. Okay, just before I continue, that's going to be a bit confusing because it's not 120 the whole way. It's only 120 from there to there. All right, going from here, same sort of deal. We need some bit of information about the right angle triangle. A to C, not really worth finding out, and it's not really attached to the non-right angle triangle. So again, we are going to go for calculating the hypotenuse of the right angle triangle, which is one of the side lengths of the non-right angled one. Now, kinds of information that we've got, you can see here that the sine rule is really my strength. That's the one I like, and that's what's turning out, or that's the method I'm using every time I'm solving one of these questions. So what I've got is the 20 degrees up here is opposite the 23 degrees there, and my 40 degrees down here is opposite the red side length I'm looking for, which, you know, it's going to be the hypotenuse, so I may as well call it H at the moment. Okay, once again, I've labelled this as extensively as possible to show you all the things. I'm going to get rid of some of this information that doesn't help, and it's just cluttering our diagram on us, and we don't want that. We want to be able to see what we're doing and what's actually useful to us. And that 120, not useful. Away you go. That line goes back down there, and that one goes that way. Okay, kicking it off. We are looking for a side length. So remember, with the sine rule, you can flip it upside down and have sine of the angle on top, as long as you do that all the way through. By doing that, you always put your unknown at the top. That makes your calculations a bit easier. So my heads up is I'm looking for H, so that's a side length. Side lengths are going on top. A over sine of A is equal to B over sine of B. Now my A, as I said, I always like putting my unknown on the left. So that is my H that I'm looking for, divided by sine of the angle that is opposite H, which is the 40 degrees, is equal to the other pair of information that I've got. That's the 23 meters divided by sine of the 20 degrees that we calculated out. Okay. This needs to move over this side again. It's been divided by the H, so we're going to multiply it. That leaves us with H equals 23 over sine of 20 multiplied by sine of 40 degrees. Equals, grab the old calculator, work that one out. 23 divides sine of 20 multiplied by sine of 40, and that gives us, I'm going to go to the nearest whole number for the ease of these examples.
43 meters. So I'm going to get rid of my H on my diagram, and I'm going to put in red, because I've coloured that side length in red, 43 meters. Now, having a look at the right angle triangle, I've got 60 degrees down there. I've got my Y there that I'm looking for, which is adjacent to the 60 degrees. So that leads us to pretty much, you can see you can do whatever way you want, and I really like this one. And it turns out to be exactly the same as the question before. We've got the adjacent, we've got the hypotenuse, we've got a missing angle. That means we're using cos. Cos of the angle is A over H. Filling in what we've got, cos of 60 is equal to our missing side length Y divided by the 43. So that means, moving it over, we need to multiply it. 43 times cos of 60 is equal to Y. Y equals, calculator time, 43 times cos of 60, which gives me 21.5. Again, going to whole numbers, 22 meters. Give myself a little bit more room. Now remember, we're looking for X. So therefore, X is equal to the 23 meters given to us in the question, which is from B to D, plus D to C, which is the 22 that we just worked out. So X is equal to 45 meters, which also means, as the question originally asked, we will ask to find the length from B to C. So you say the length of B to C is equal to 45 meters. And that's done. You know, normally I'd say any questions, but it's kind of hard for me to answer them right now. So I will leave it at that and move on to our third and final example. Again, a reminder that if you're feeling pretty good about this stuff and you want to just get started, open up the applications of trig lesson. I believe it's lesson number 7 in the trigonometry folder, and pull up the questions. Okay, last example. Find the value of theta and then find the value of y. So this one stuffs up my method a little bit because I like doing things my way, and this one's telling me, no, you pretty much got to do it the way I'm asking you to do it. So, what do we got? We've got a whole bunch of side lengths. We're not given any angles, but we are asked to find out an angle. So because there is only one angle in this question, that pretty much says right away you're going to be using the cos rule. Because, remembering the sine rule needs 2 angles. Alright, this one getting a little trickier and really not giving us much information on where to start. So what we need to do is have a look, mark that angle on there. In terms of using cos rule to find out either the missing angle or the y length, we can't really do that because both of those bits of missing information are a part of the formula, and you can't use a formula to find 2 things at one time. So that one's out, which means we can't really do much with our non-right angle triangle. Moving to our right angle triangle, we've got 61 and we've got y, and we have no angles. We don't really have a way of finding out any of the angles, so that's out as well, which leaves us only one thing left that we can do, and that is to say, like in our first example, you can use the entire triangle itself, which is just one big right angle triangle. And in terms of that triangle there, we've got an angle, the hypotenuse, and that 61 is opposite the angle. So by enlarging our view and taking into account the fact that our 2 triangles actually make a triangle themselves, we now have a way of finding out one of those missing bits of information, and that is the angle. So using the information we've got opposite, we've got hypotenuse, and it's a right angle triangle. which means we are using sine. And sine is opposite over hypotenuse. Fill in our information. Sine of our missing angle is equal to 61 over 83. To separate just the sine away from the theta, remember that we use second function, whatever trig one, so second function sine of 61 over 83. Grabbing my calculator to work that one out. Remembering here, really good idea, in fact, compulsory that you use your fraction button, so either ABC on the Sharp or the actual fraction button on the Casio. That will tell you, or tell your calculator, that you're trying to do inverse sine of that fraction, as opposed to just inverse sine of 61, getting that answer and then dividing it by 83, which will give you an answer far too small for what you want. Okay, mine comes in at the nearest whole number of 47 metres, which, wait, not metres. Whoa. It's not a length, it's an angle. So theta, marking it in the same colour as what it's marked on the diagram, is now 47 degrees. From this, we now have to work out the last piece, which is y. We now have 15 metres, 83 metres, y, and 47 are the information given to us in the non-right angle triangle, which, as I said at the start, means we are using cos rule. Alright, remembering back to our cos rule, it is c squared equals a squared plus b squared, so there's Pythagoras, but it's not a right angle triangle, which we need for Pythagoras to work. So that means we need to put in all this other stuff to make it account for the fact that it is not a right angle triangle. Just formulas on your formula sheet, don't forget that. Okay, remember A and B, it doesn't really matter which ones they are. The important relationship is between the C side length and the C angle, because they are the ones that need to be opposite each other. Alright, let's do this. 15 squared plus 83 squared minus 2 times 15 times 83 times cos of 47 degrees. I'm going to leave it right there and plug it straight into my calculator as is. 15 squared plus 83 squared minus, open brackets, 2 times 15 times 83 times cos of 47. Close those brackets. That leaves me with 5,416 to the nearest whole number. Now that looks a little big, but remember this is still c squared. So c is equal to the square root of that number, and that gives us, to the nearest whole number, 74 metres, which you can be pretty happy with. 74 metres is y, which is there. It's the hypotenuse of the smaller right angle triangle. 74 is bigger than 61, so I'm going to give that the 2 thumbs up. Okay, that's it in terms of my 3 examples. It's taken a very long time to get there, so kudos to you if you've actually stuck around and watched all 3. But at the same time, you now haven't left yourself much time to get the work done in the lesson. From here, I will post these working out, as I normally do, to the Schoology Trig folder. And at the end, it will be, the textbook questions will be attached. If my memory serves me right, it's a bunch of just pick a few from each page. Where level 1 and 2 pick a few more from the earlier pages as opposed to the later ones, and level 3 you pick fewer of the earlier questions and more of the development ones to get more of a feel of the exam questions. Alright, thanks very much for watching and good luck.